What if we could give our bodies a set of instructions, not just to heal, but to rebuild perfectly? Well, today we're diving into a technology that's taking a massive step toward printing away one of the most common sources of human pain. It's like we found the body's own secret code for regeneration.
Seriously, it's true. For all the amazing things our bodies can do, heal cuts, mend broken bones, there's one vital piece that, well, just wasn't built to last. And once it's damaged, it kicks off a countdown to chronic pain for millions and millions of people.
So what exactly is this flaw? It's something most of us never even think about until, it starts to hurt. Okay, so deep inside our joints, we have this stuff called articular cartilage. It's basically the body's shock absorber, but it has this one fatal weakness. It has no blood supply, no nerves. And that means if it gets damaged, it can't send out an SOS for repairs like your skin or bones can. This inability to heal itself is the root cause of osteoarthritis, a condition that affects hundreds of millions of people all over the world.
For decades, the only real answers have been managing the pain or, a full-on joint replacement surgery. But now, a wild new technology is offering a completely different path. Welcome to the incredible world of 3D bioprinting. Forget plastic or metal. Here, the printer uses a special gel called a Bioink, and it's loaded with actual living cells. The idea is to print a living scaffold that your own body can then use to grow brand new healthy tissue right where you need it most. Now, one of the top candidates for this Bioink is a mix of Silk Fibroin and Gelatin. I mean, it's got a lot going for it. It's biocompatible, cells love it, and it really encourages them to form cartilage. But, and this is a big but, it has a huge flaw. By itself, it's just way too weak. Put it in a working joint like your knee, and all that pressure would just cause it to collapse. Not good. And this is where the real breakthrough happens. Researchers figured out how to add a secret ingredient, a tiny nanoscopic architect that doesn't just make the ink stronger, it completely rewrites the blueprint for healing itself.
Say hello to metal organic frameworks, or MOFs for short. These things are unbelievably tiny, cage-like structures. The best way to think about them is like programmable Legos, but on a molecular level. They're built from metal bits connected by organic molecules, which creates a structure that's both super strong and incredibly customizable. The specific star of this particular show is an iron-based MOF, this one right here. And that little Fe for iron, that was no accident. As you're about to see, the iron at its core is absolutely critical for speaking the same biological language as our cells.
So these MOFs basically give the Bioink three incredible superpowers. First, they act like rebar in concrete, making the whole structure way, way stronger. Second, and this is the really cool part, they aren't just sitting there. They actively send out biological signals that tell the stem cells exactly what to do. And third, they're programmable. Scientists can tweak them to do very, very specific jobs.
So, what happens when you combine this nanoscopic architect with that silk gelatin Bioink? Well, you get something completely new. As you can see in this diagram, the MOFs don't just get mixed in. They actually weave themselves into the silk and gelatin, forming this complex interconnected network. What you end up with is a true biohybrid material that has the best of both worlds. It's got the biological friendliness of the original ink, but now it has the strength and the intelligence of the MOF.
And the difference this makes is just staggering. The standard ink is weak and fragile. The new enhanced ink is strong enough to actually bear weight. The printability goes from just good to superior, which lets you build much more precise structures. But here's the most important part. You go from passively supporting cells to actively instructing them. We're not just building a house for them anymore. We're handing them a detailed blueprint for building perfect, healthy cartilage.
Okay, that all sounds amazing in theory, right? But the real question is, does it actually work? Well, let's take a look at the evidence from the lab.
What we're looking at here is the ink at the nanoscale. On the left, you see the original ink is pretty smooth. But look at the right. The MOF enhanced ink is this complex, rugged landscape. And that texture is absolutely crucial. It creates a sort of nanoscale climbing frame, giving the living cells way more to grab onto, which encourages them to lock in place and get to work building.
This chart basically shows us what the cells were actually doing. That tall green bar? That shows that the genes responsible for building healthy cartilage were turned way, way up. And that shorter bar? That shows that the genes for creating defective, kind of bony tissue were turned way down. So the MOFs weren't just giving the cells a home. They were giving them perfect, step-by-step instructions.
And here's the proof in the pudding, a number you can actually measure. After 28 days, the cells in that new, MOF-enhanced ink produced 1.6 times more collagen. That's the key protein that makes up healthy cartilage. That's not just a tiny improvement, that is a massive leap forward.
And this right here is the payoff. This is the visual proof. On the left, you've got the standard ink after 28 days. It's okay. But look at the right. That's the enhanced ink. All that glowing green? That's healthy collagen too, the exact stuff you want. It's visual confirmation that the better texture, the right gene expression, all of it, it works. The cells followed the blueprint perfectly and built a dense, healthy network.
The results from the lab are just so clear and compelling. So, what does this all mean for the future of medicine?
Well, the vision is something like this. A surgeon takes a scan of your damaged knee. They print a custom-fit scaffold using this incredible Bioink, loaded up with your very own stem cells. They implant it, and that scaffold gives you immediate support while also telling your cells to rebuild perfect new cartilage before it just harmlessly dissolves away.
This really represents a fundamental shift in how we think about healing. We are moving way beyond simple patches or passive repairs. This technology brings in a whole new paradigm, active regeneration, where we literally give our bodies the precise instructions they need to pull off a flawless repair.
This research just opens up such a tantalizing possibility. It makes you wonder, if we can create the perfect blueprint for cartilage, what other parts of the body could we learn to rebuild from scratch? Could we really truly one day print an end to the pain of arthritis? Based on what we've seen today, the future of healing looks stronger and a whole lot smarter than ever before.